Okay, so these are notes on bonding. We've been talking about elements and atoms and what matter is, and now we're going to look at how those basic particles, which are the atom, combine to form more complex substances such as elements and compounds. And we're not going to talk about it this time, but those elements and compounds then come together and form mixtures, and ultimately the mixture we really want to look at are rocks and minerals. So for today we're looking at something called chemical bonding, and chemical bonding talks about the joining together of atoms to form compounds and elements. And these can be elements which are the same atoms, or compounds which are different. So if we're looking at elements, we might look at oxygen, O2, okay, and that's just, this subscript tells us how many atoms. O2, that's an element. It's the same atom. So let me write that. And then the compounds are the different atoms. So an example that we always talk about is H2O. Okay, and these are joined through chemical bonding, but they have different. So we have a hydrogen and an oxygen. That is going to be a compound. I'm just going to put a C. So the main difference is the elements have the same atoms and compounds have different. How this happens, though, and why it happens, is through the use of electrons. So if you want to know how something's going to bond, you need to understand the electrons and how many they have in their outer shell. And the chemical bonding is really based on this octet rule. And you probably know prefixes and suffixes, and octet means 8. And this says elements or atoms like to have a full outer shell. So if we were going to draw an example of lithium, Li, it has an atomic number of 3. And you should know that the atomic number tells you how many protons. And when we're looking at elements that have no charge, that are not ions or are not isotopes and have extra neutrons, we assume that 3 protons equals 3 electrons and 3 neutrons, that they're all the same, unless we're told differently. So that's kind of how we have to look at it. So if we were going to draw this Bohr model, a Bohr model just shows you with the nucleus. So we would draw a circle, and then we would just say 3p, 3n, and then you draw the electrons around it. So since it has 3 protons, it has 3 electrons. You should know from your middle school days that the first shell always has 2. Every single element on the periodic table has 2 in this inner shell. That's how many it can hold. And then the outer shell can hold up to 8. The only one that does not have 2 in it is a horrible shell there. Let me fix that one if I can. Okay. And the only one that does not, though, is hydrogen. It has 1 because it only has 1 proton. All the other ones have at least 2 in this. So then lithium has 3, so then we have this extra electron here. Okay, now this atom here wants to follow the octet rule. So this says this can hold 8. It only has 1. So it has 2 options. It can bring on 7, right? So it can add 7, or it can get rid of -1, take 1 away. And then you might say, well, it doesn't have anything then. But then if this electron is in here, this shell is gone, and then the inner shell is full, and that has a full shell there. So that helps it fulfill the octet rule, even though there's not 8 in here. Okay, so and this is a side note here. This shell, the outer shell, is called the valence shell. The one where all the bonding behavior takes place is the valence shell. So then, so lithium loses. So if you think about this, though, what's easier? Do you want to take on 7? 7 separate things have to happen, or just get rid of one thing? that has to happen. And also what could happen is it could share. And we're going to talk about why it may not share or may share in a minute. And this can also, over here, it could share its, 1 or whatever, but this one is going to either give off, because it's an ionic compound, but it's going to either give off 1 or take on 7. And this one's going to give off 1. And that's kind of the rule. And if you're a compound like oxygen, let me erase this here, all this stuff. Let's give it a different perspective here. If you're a compound like oxygen, it has they all have 2 in this one. And this could be 8p, that's the atomic number, 8n. And then in this one, it has, I'm just going to leave it as 6. Actually, let me redo it one more time. So it is 1, 2, 3, 4, 5, 6. So this needs +2. It either needs +2 or it needs -6. You think about what's easier, +2. So this one actually has 2 behaviors where it can give off 2, but it could also share 2. So if you remember H2O, it shares with 2 hydrogens. So if you have a hydrogen over here, it has 1 in its outer shell. I'm not going to draw the nucleus. Then it has another hydrogen over here, and here's its outer shell. I'm not going to draw the nucleus. And then what can happen is these share, and this is a covalent compound. So this shares this one. They each share 1 electron with each other. And then if you look at this outer shell, there's 1, 2, 3, 4, 5, 6, 7, 8. And then hydrogen needs 2 in its inner shell, 1, 2. 1, 2. So that's a covalent compound. But either way, this is about getting a full outer shell, whatever the shell is, and they do it through either sharing electrons or exchanging electrons. So let's move on. Okay, and like I said here, kind of introduced this already, they can be shared, and when they share electrons, we call that covalent. Covalent equals shared. And that's right here. Means the same thing. Okay. Now covalent compounds only form, they only share when they're non-metals. So if you look on your periodic table, you start looking where carbon is, and that's going to be group 14. To group 18. So if you're in that group, starting with carbon, you don't want to include silicon. Some of those are other metals as well, but this is non-metals only. Group 14, starting at carbon, nitrogen, oxygen, sulfur, all those kind of things. Those are non-metals. They share their electrons. Okay, but then we have the other ones, exchanged electrons. Okay, and they form ions, and those are called ionic compounds, because they form ions. And these are metals. So if any one of the compounds or any one of the atoms in the compound is a metal, then it's an ionic compound. So an example would be calcium oxide, Ca2O. So now this is a non-metal, but this is a metal, so it has to be ionic, it has to share. Okay, so just keep that in mind whenever you look at a compound. Is any one of the atoms that are in there a metal? If they are, then it's a ionic compound. So you just have to look at the formula itself, and this is called a chemical formula. It lists the elements and the atoms that are in there. So if we look at these, for these to form, calcium or oxygen forms an ion. And I'm going to show you that here. I'm going to erase this. So hopefully if you have this, you've this written down, and we'll finish up these notes and try to explain what these terms mean here. Okay, so I'm going to erase this and then go down a little further. So then we have these terms cation, anion, and polyatomic ion. Okay, so if you look at an element, a good example of a cation is, we're not going to do calcium, we'll do an easier one. We'll do sodium, Na. So sodium has 11. Okay, so it has 2, and then it has 11. If you look at the atomic number on the periodic table, it has 11 protons, and that means it has 11 neutrons and 11 electrons. So then the first shell will be 2, the next one is 8, then it has this lone thing here. And what happens is, to get the full outer shell, if it just gives this one off, it has a full inner shell, and that's 8. So it's going to give off this electron, and this electron is negatively charged, so it loses one of its negatives, and the charge of this then becomes +1. Okay. Then if we look at another one, such as chlorine, or we'll go fluorine, it has an atomic number of 9. So then if we're not going to put the nucleus, but you need to know it's got 9 protons, 9 neutrons. And then if we go, there's 1, there's 2 there, and then we're going to have 7 in its outer. 1, 2, 3, 4, 5, 6, 7. Now it needs 1, and here's sodium. It has this extra one, so then it takes that one on. We'll make it blue. So now it has taken on an electron. It has a full outer shell, and then it added a negative, so then its charge becomes negatively charged. And then these are opposite charged, so they're attracted, and then they form a compound, sodium fluoride, which is NaF. And that's how an ionic compound forms. It doesn't share like covalent. They exchange electrons, they form ions, and then they form a compound. If it's a positive ion, that's a cation. So calcium is a cation, and then fluorine's a negative ion because it's negatively charged, so it's an anion. And then we have these polyatomic ions, which are groups of elements like CO3, and then they form a -3 charge. So that's a group of atoms joined together that have a charge, and this would be carbonate. You can just write that down. Okay, that's your notes on chemical bonding. Make sure you annotate these as you're watching them, and then turn them into me and tell me that you've got these done. And that's it.